Hello, hello.
Hi, can you hear us?
Yes, yes.
Hi, how are you?
I'm really good. What about you? How are you?
I'm good. I got my team here, my crew. Oh wait, you can't really.
Okay. Hello, guys.
Oh, sorry, it's hard to see them really quick. 1 second.
Okay, okay. No worries.
Yeah, that's all right. Let's see if this is a bit better. Can you guys scooch in?
Hello, hello. How are you? Nice knowing you.
So I have our president of the club, Karel Grigos. She's also a recovery member. I have Matthew Stein. He's structures lead. We
Perfect.
got Justin, avionics lead, and then we got Richie, our propulsion lead for this year's hybrid rocket.
That's really great. Well, my name is Diego. I am the general team leader. So nice knowing you guys. We have been in contact here in IG. So it's a real pleasure to have you here in the fourth episode of the Trust Just Trust podcast of Space Dragons Rocketry Team. So if you haven't heard about us, well, we are from Mexico, and we are so proud to represent our country here and in the Spaceport America Cup, now IREC, and it's a real pleasure to talk with you. So nice to meet you.
Nice to meet you.
Perfect. Well, we're going to start. We are just want to talk with you, to talk with some topics about rocketry, because we are all passionate, just like you, about the rockets and watch the rockets fly. So uh, we want to share with the people, with Mexican engineers, with Mexican people in general that are passionate of this topic, to talk about rocketry. And we have a really great team, just like you, here today. So, first of all, if any one of you want to talk about your team, about your roles individually, so it will be great.
What do you want to maybe start with introduce the club?
Yeah, I want to talk. Okay, so I'm Karau. I'm the president. And a little bit about our club is that we are mostly a rocketry club. However, we do also do other stuff related with space. So we have an astronomy section as well to this club, and we also do HPR, so high power rocketry certifications for our members. And we also launched the weather balloon last year. So we have a broad range of things that we touch, but we are mostly focused on the IREC competition. But these guys next to me will be able to talk more about the technical aspects of the club, as they are technical leaders respectively. So I'll let them introduce themselves.
Okay, perfect.
Hi, I'm Matt. I'm the structures lead. One of my favorite things about UB.SEDS is that we're almost completely SRAD. So a lot of teams will buy components like body tubes or internal structures. We make everything in-house, so we do all of our own composite layups. We make our body tubes, we make our nose cone, we make our boat tails, and even our fins. So it's really cool to see it all come together just by your own hands, instead of just going SRAD by buying or like making your own motor.
My name is Justin. I'm the avionics lead for the team this year, and just to build on what Matt said, we do pride ourselves on being completely SRAD. So for the avionics, for example, we design everything with All Team Designer. We take students that have never worked with electronics or software before, and we teach them how to make circuit boards. I have a few here. We don't buy anything off the shelf. We do everything completely custom, besides the required COTS components that you need. And it's just super satisfying seeing us like build things from the ground up and then eventually putting it in the rocket and being able to do all these things like control the parachutes and the GPS. So yeah, we're very passionate.
Perfect. Thank you.
And I'm Richie, I'm the propulsion lead, and yeah, making rocket motors is super cool, and especially the part where you get to test them. You know, you set them off and it's loud, you know, you get a big plume of smoke, some flame, and it looks so cool. And you know, we have a lot of experience with solid rocket motors, but this year we're trying a new thing and we're doing a hybrid rocket motor. So I think the team is ready for a challenge like that.
Perfect. Well, thank you, guys. As we mentioned before, we have heard a lot of you there in IREC. So we want to know about you, about your last performance in the last Spaceport America Cup competition. So I don't know if some of you want to talk about the performance that the team had, the rocket had, or in general just your awards in certain uh, different well categories of the competition.
I can take that. Yeah. So last year's competition was a really successful one for us, actually. We had a final apogee of, I want to say it was 10,200-ish feet. So really close to the 10,000 foot target there. Our recovery, what happened? It was
I can talk about the recovery part. So the launch itself went really good, and we did manage to recover the rocket. However, we had a bit of a problem with our parachute, where it didn't fully deploy from the drogue to the main. It didn't inflate properly. It created a bit of a wind tunnel because of an issue that we can talk about later if you're interested. But it hit the ground really, really fast, and we actually saw the rocket bounce like 10 feet up in the air after landing. But it did survive thanks to the great work that the structures team did. But yeah, we had an overall pretty good launch, but the recovery aspect did suffer a little bit.
Perfect. Those the I don't know the airframe of the rocket had any damage after the rocket go down?
Yeah, I mean, minimal. Just a few cracks. We still got full 150 recovery points. Our payload bay actually crashed through its supports and into our avionics bay, and it's all bent out of shape now, but we still got full recovery points, and it's still very much intact and like on display in our lab.
Oh, perfect. I think that all the teams that participate in the IREC now have a lot of problems, or we had a lot of problems with the rocket, with the organization. How do you change all of those aspects in your rocket, in your organization, now in this 2025 IREC competition? I don't know if you have any change on the team or in your way to acquire some knowledge about different topics or calculations.
Well, I can say switching to hybrid is definitely a massive challenge. We've changed almost everything about our rocket. In trying to keep things similar, because we had a massive turnover of leadership, so we're actually all first-year leads. But like I was saying, the rocket structure, we tried to keep mostly the same, but it changes the entire bottom end of the rocket, having that separation of the fuel and the oxidizer. And our rocket, I think, is projected to be 12 feet tall. Or no, taller, like 14, right? 14 feet tall, yeah. A lot taller than our previous rocket. And I think a big way to get information and knowledge through this has just been speaking with other teams like you guys. And you know, the IREC Discord server, there's a lot of communication in there. Just talking back and forth, seeing like, hey, like, we're trying to do this. What do you guys think? Or what did you guys do last year that worked for you or didn't work for you, you know?
Perfect. That's so. Yeah, I think that it's a lot of teamwork. You look like a real teamwork with your captains or your team leaders. So it's really good to see that aspects in a big team just like you. Uh, Now, as far as I know, I think that you are going to participate this year with hybrid rockets, well, rocket motor. So, uh, what those aspects change your rocket? I know that you change everything, but I don't know if the SROT hybrid rocket had any other complications in your team, in your experience in IREC. I don't know if you can talk about that.
Well, I mean, Richie could talk about this a lot more too, but from a design perspective, everything is changing from the control, because before, I mean, we essentially just kind of lit a match under it and it would go. Now we have a whole complex fill sequence, so we need a ground station now where we can monitor all our pressures in the tank. If the pressure gets too big, they'll literally take our rocket out into the desert and shoot it because it's all kind of.
We're gonna vent it.
We're gonna vent it, hopefully. But if it doesn't vent, then they do have to do that. So we constantly have to have our instruments up and running. We have to make sure we're getting radio telemetry back to our ground station so we can monitor everything. We also have dynamically moving valves that we're controlling electrically, and we need to make sure those are moving at the right time, or we could risk damaging the rocket and potentially disqualification. So a lot more pressure, and I'm sure you can all speak on this too. But I think just having a motivated team of engineers and students that really want to do this, I think it's completely possible.
Perfect. How long have you ever been working in this motor?
I can say we've been working on this hybrid for quite a while now. We're working on it in collaboration with a research center that's been around for, I think we're on our 4th year now. And we've actually successfully built a small-scale hybrid rocket motor, and we've tested O2 and KMA. And so this full-scale one is actually new. We just finished the design, and we're moving on to the manufacturing phase now. So yeah, it's been in the wraps, and the concept of a hybrid rocket we've worked on for a while now, but this actual motor is a very new thing for us.
Perfect. That's great. I know that it's the secret formula of your rocket, but I don't know if you can talk about a little bit about your oxidizer, your propellant that you're going to use this year, how those aspects change.
Yeah, so very different from a solid to a hybrid. So obviously with your solid motor, right, you have your fuel and your oxidizer mixed into one batch, and then that just burns, and it's a self-oxidizing process, so it'll just burn no matter what, right? So with a hybrid, we're separating our oxidizer and our fuel. So in our oxidizer tank, we're going to be storing nitrous oxide. And in our combustion chamber, we're going to be storing our fuel, which is going to be a paraffin wax-based fuel. We're going to have some additives in there. We're making a 3D printed ABS structure to kind of, wax is it's candle wax. So it's very weak. It'll crumble under its own pressure. So the structure gives it strength. And then we're also adding carbon black to it. Carbon black makes it so that the wax isn't see-through, so you eliminate like radiative heat and get a more uniform burn from the port outward. So.
Okay, perfect. Well, thank you. It's really interesting because here in Space Rounds, we are currently working and initiating with COTS. So we try to acquire a little bit of knowledge about SRAD motors. So I hope in a few years we can do that big step. So I don't know if you have your own simulator for your rockets, if you are still using some commercial simulators, or just like that, maybe you calculate everything by yourself in your notebooks, or what's that process of you analyzing those simulations?
Yeah, so a member who's not here right now, our dynamics lead, Alex, he actually built his own simulation software over the summer, like from the ground up. It's called Post Rocket. He's doing some incredible work right now. Like he's adding like 6 degree of freedom simulations, and he's like tailoring it specifically to hybrid, which it's been really incredible to see that like come along.
Okay, that's great. Well, we don't have the opportunity to be in your university. I hope that someday that happen, but can you talk about your laboratories there, about your maybe you work in your your classrooms or something? I don't know if you have your own laboratory. How is your organization in that sense?
Sure, I can take that one. I don't have a frame, but
No, it's I know.
okay. So our main workspace is a lab that we do have in the university in one of the engineering buildings. It's not a huge lab space, but we do have like a big workbench with a CNC that we built in-house at the back, and a lot of space for the storage of all our materials and everything. And for other parts of the rocket that aren't super hands-on, we do rent out classes in this same engineering building that have computers where a lot of like the avionics, dynamics teams can do a lot of their work. If it's not necessary for them to be in the lab space, we tend to like not have them in there. And even for the recovery section, we do also rent out another room that just has like benches where we can do a lot of the sewing of the parachute, because we do that in-house as well. So we have a very scattered work environment. All the different sections work in their own separate space, and then all the leads just get together to discuss everything afterwards. But yeah, it's not a super concentrated space. We don't really have the money or facilities for that.
Yeah, we don't have the money to for a big laboratory. So I think that we have the same problem. So that's really interesting. Do you test your rocket or your deployments maybe in the laboratory, or do you have another space to do the tests?
Yeah, so we run a lot of separate tests. We've never done a flight test. We're usually down to the last minute, finishing things up at competition. So a flight test is very difficult. That's the goal for this year, is to get a flight test done. But we do run a lot of separate tests. Actually, right now our recovery lead isn't here because he's doing a drop test off the roof of one of our buildings. So he has a payload attached to his parachute, and he's just throwing it off. And we do our motor tests separate. We do a lot of tests. We just have never done a flight test.
Okay, that's really good. Yeah, I think it's we prefer to maintain the integrity of our laboratories. So it's really interesting that you do it in a different way. Um, how many of you guys are going to this IREC competition? Do you have now defined how many people are you going to be there, or what's the process of selection that you have? It's based on your performance, maybe, or about your knowledge or the experience. I don't know how your selection of those.
So last year we had 24 people go to competition. This year we're hoping to have a similar number go. And how we choose who goes to competition, it's basically the leads who decide who goes. So because we have our club very divided into like the specific subsections, we have a certain amount of people go from each subsection. So the lead will choose the people under that section that maybe have the most knowledge, the most potential, have shown the most interest, and like have potential for future years to keep contributing to the club. And it could be like a really good learning experience for the people going. So there's a lot of factors, but it is the individual leads that choose who goes. But we do try and make it a like balanced process, and really be fair in who gets to go.
Yeah, and to add to that too, it doesn't matter if you're a freshman. If you just show interest and you show that you want to work and you're willing to learn, then we will take you as well. And then you can get that experience and you can take that with you. And it's like I went when I was a freshman last year, and it was a life-changing experience. We went across the country, down to New Mexico. It was so much fun. So yeah, we offer the opportunity to like anybody as long as you want to work. So it's really cool.
Yeah, I think that's a really cool experience. The IREC competition. Just watch the different rockets that the different universities have, and we learned about all of us, and we still improving just by inspiring with guys like you. So it's really cool. I think that the fact that in here in Space Dragons are so fascinated about you, it's the hybrid rocket. Maybe I want to know if you have any recommendation for any team that want to try for the first time an hybrid rocket, how complex it is. So your experience can help us to improve. So if you have any recommendation.
I'll take this one. My recommendation for any team who wants to make the jump from solid to hybrid is definitely have a fleshed out design before jumping. I think, and I'll admit it. I'm not happy with how long I spent designing the motor. I think the first semester we spent a lot of time going through the nitty gritty and making sure this thing is going to work. And I'm getting kind of a late start to manufacturing phase, so it's definitely not something you want to just jump into. You want to be sure you're ready because and financially too. One of the biggest hits we're taking right now is just building up the infrastructure for all this. One of the things with nitrous oxide is because with our solid motors, we would test them upside down, right? So you'd have your flame shooting up and then a load cell beneath it, and you'd get your thrust like that, right? But nitrous oxide, you can't really do that. You want your liquid separating the vapors from the actual combustion. So we had to, I think I just finished building a new test stand to test the motor vertically the other way, and that thing ran me up about $1,200 of our budget. The infrastructure is just, make sure you have it before making that jump. Because now I'm trying to build a rocket motor and build the infrastructure needed. Because you also, at competition, bring your own launch rail too, which we don't have the launch rail yet. So that's another thing I'm figuring out while also figuring out the motor. So a lot of moving parts. So just be ready for that if you're looking to make the jump.
Okay, perfect. Thank you very much. Uh, I have a question with the structures lead because we always have a problem. We always have a problem with the rocket, with the structure. Maybe when you are packing, maybe when you think that you already have everything ready to go, and when you arrive to the competition, something went wrong. How do you solve those problems in your area? I think that there's a lot of problems too, just like energetics lead. But in structures, how do you solve those problems?
Yeah, no, we definitely always have a lot of problems. Last year at competition in the field, we were getting ready to integrate, and I ripped the threads out of the piece. And I was just looking at it in my hands for a solid 5 minutes, like, how did I even do that? So I had to, on the fly, I like took a cotter pin and like banged it in with a hammer and was like, I guess it's good enough to fly. It's just kind of like looking around and seeing what you can use, especially out in the field at competition. There's not a lot you can do.
Yeah, it's just solve with anything you have in your hand or anything that you have in your environment. You need to solve at any cost. So it's really, really cool. Uh, well, I don't know if someone in here in the live have any question of the team of sets that your teammates. I don't know if you anyone here in the chat have any question. We are going to wait a few minutes, maybe to take time. Well, I think that it's everything that no one wants to ask anything. So thank you guys for joining. We are really, really. Sorry. Now we have a question. Here, what will you say it will be the biggest challenge you will face with your new hybrid motor during competition?
Biggest challenge is certainly going to be the filling on pad. Yeah, because there's a lot of things that can go wrong there. You have a short window where once you start filling, a timer starts and your rocket has to be up in the air before that timer finishes. And if anything goes wrong, if your arm can't detach from the rocket, if the rocket gets too hot, if you have an overpressurization, anything could happen. It's fully up to us when to tell it to stop filling, right? So nitrous oxide has a tendency, if you have a container and you fill it to the top, it'll just decompose and then it'll blow up. So hopefully we don't have that. But yeah, nitrous oxide is not a fun chemical to work with. Definitely dangerous. So yeah, that's processes where I anticipate the most amount of problems.
Okay, perfect. Well, thank you. So I think that there's no more questions. So I want to thank you again, guys. It's a real pleasure to talk with you, to learn about you. You are an inspiration for all of us that want to uh, maybe take the big step, isn't it? Just like build a hybrid rocket motor. So it's really huge inspirations for all of us. And if there is no more questions, I think that we hope to see you there in IREC this year and talk with you again and still learning and have a really good time together. So thank you very much again. It has been a pleasure. And well, thank you. I think that's everything for us.
Cool. Yeah.